Lesson 21, this is the law of detachment and law of syllogism. So first of all, we're going to go over a definition. Deductive reasoning. Deductive reasoning is the process of using logic to draw a conclusion from given facts, definitions, and properties. So deductive reasoning uses facts, rules, okay, or definitions, and properties. Okay, so let's do this example. So the bakery makes fresh bread every morning. And it is morning, therefore the bakery has made bread. That would be a deductive reasoning kind of thought. Okay, so if I said that it rained outside, a good conclusion to draw from that is that the ground would be wet, right? Unless you have some kind of canopy. But deductive reasoning is just using that to using logic to draw a conclusion about the given facts that we currently know. Okay, so you guys use this all the time. You just never call it deductive reasoning. So we're going to go through a few examples. Now, I'm not going to write them down. I'm just going to say them aloud. Guys, I'm not going to compete with you over there. I'm going to say them aloud. If you want to write them down, you can write them down. Okay? I'm just going to give them, and then we will see what conclusions we can draw from them. Okay? Example 1A. All human beings need to breathe. We are all human beings, therefore, what? We need to breathe. Okay? These are fairly obvious. Okay? They're really easy at the beginning. So the way we would answer the question is we'd begin it with a therefore. We're going to use it in the form therefore. So we'll say therefore, comma, and then we include whatever statement we need to do. Okay? So on part B it says all the chess team members won their opening match in the last tournament. So Jeffrey is on the chess team, so what conclusion can we draw? Therefore, what? Therefore, Jeffrey, say it again, Call. Won his opening match in last tournament. Okay, on C, all the women in the royal family were wearing hats at the ball. Melissa is in the royal family. So, therefore, Melissa was what? Wearing a hat. Wearing a hat at the ball. Okay? So, it's just drawing logical conclusions from what we know. Okay, any questions on example 1? No. Basically, that's common sense, okay? You just have to write it in proper form. Therefore, comma, whatever we can draw from that conclusion. Now, the law of detachment. Okay, I'm going to read it, and then I'm going to try to simplify it, okay? For statements P and Q, remember P is the hypothesis, Q is the conclusion. When if P, then Q is a true statement, so when the original conditional statement is true, and P is true, then Q is true. Okay? So, in other words, in an if-then statement, if P, then Q, if the first part P is true, then the second part Q must also be true. Okay? So, I'll give you an example from it. If it is Monday, then Mark will go to work. Today is Monday. So, notice I go if P, then Q, and then I say P is true. Okay, so I give it if P, then Q. After that, I say P is true. And then what conclusion can I draw from that? I say, therefore, Q is true. Good. Okay, so reading that example that I just had, if P would be if it is Monday. So there it is, if P. Then Q, Mark will go to work. So today is Monday. I'm stating that P is true. Today is Monday. Therefore, Mark will go to work. Okay? That's all it is saying. That's using the law of detachment. Okay? What we just practiced, those 3 examples, was just the law of detachment. So it's creating a logical conclusion based off of the facts. So example 2, and we're going to practice this just a little bit more right here using that law of detachment. And again, I'm just going to say these out loud, so try to follow along in your book. When it is cold outside, I wear my warm jacket. It is cold outside today, therefore, I will wear my warm jacket. Obvious, right? Okay. On B, if an angle is acute, then it cannot be obtuse. Angle D is acute, therefore, okay. I had 2 different answers here, so I'm going to re-clarify. Angle D cannot be obtuse. So we're re-repeating the Q part of the statement. So if an angle is acute, then it cannot be obtuse. We can't say that it is acute because it could also be right, correct? So we want to clarify that. If a number is even, then it can be divided by 2. The number 104 is even, therefore it can be divided by 2. I use this with you guys all the time. I state what is true, and then I ask you a question after. I'm using the law of detachment. It's just inadvertent. We don't notice that we're doing it. Okay. Then there's a second one called the law of syllogism, and I'm not even 100% sure that I pronounced that correctly. Syllogism. So syllogism, almost like syllable syllogism. Okay. Now this one to me is just a little bit easier. So it says, if Q then, or sorry, if P, I said that wrong. If P then Q. If P then Q, and then they include another statement that says, if Q then R. Okay. If those are true statements, then we can conclude that if P is true, then R must also be true. Okay, now that's a whole bunch of stuff that doesn't really make sense. So I'm going to put it into perspective for you, and it's fairly obvious when we get down to it. Okay, if there's a power outage, then the freezer doesn't work. And if the freezer doesn't work, then the ice cream will eventually melt. So I can conclude if there's a power outage, then the ice cream's gonna melt, right? So we're gonna have to eat the ice cream. We don't have a choice, Mom. That's what we're doing, right? It's a matter of survival for us, not the ice cream. Okay, so is that a little more clear now that we have that example? Do we need to do another one? Okay, so I expect that we would know the answers to the example 3 then. So on example 3, ooh, that's a crazy word. If Annika jumps higher than 5'3" in this event, then she will win first place and get a new state record in Class 1A. So if she jumps higher than 5'3" in this event, then she will win first place. So we're going to try to use the law of syllogism here. If Annika wins first place, then she will receive a medal. So we can conclude that if she jumps higher than 5'3", what will happen? She'll receive a medal. Good. Okay. Won't work for call, but it'll work for a girl. Okay, next one. On example 4, we're going to see which one is which. We're going to see if we can differentiate between which law goes where. Okay. So on example 4, we're going to see which one goes with what. Remembering that the law of detachment is if P then Q and we use a therefore. Okay, if P then Q and we find a therefore. The law of syllogism has a first statement, a second statement, then a second statement, a third statement, and then we put them together first and third. Okay, so these should be pretty easy to differentiate between. So on example 4, A says if Maria wants to see a movie, then she goes to the theater. If Maria goes to the theater, then she buys popcorn. Now, it's not asking for what the statement would be, but what law are we going to use? We're going to use the law of syllogism. And when we put those two together, we're going to say, if Maria wants to see a movie, then she buys popcorn. Okay, you can't go to the movies without buying popcorn. That's like an unwritten rule. Okay, on B. Well, then don't go to the movies. Okay. Example B. Example B, guys. If it is raining, then I'll take an umbrella to school. Today, it is raining. Therefore, I will take an umbrella to school. What law did we use?
Syllogism. No. The first one, right?
The law of detachment.
Right.
On C. Now, this is where they love to confuse you. This sounds like a Dr. Seuss book. Okay? All bibbles are baubles, and all baubles play bubbles. It's on your book. All bibbles are baubles, all baubles play bubbles. So I've now stated what kind of things. Look at the middle of these, okay? So look, all bibbles are baubles, and then we see baubles again. Notice that in law of syllogism we see Q, and then we see Q, okay? So keep that in mind. It's kind of repetitive in the middle. So all bibbles are baubles, and all baubles play bubbles. So therefore it's going to use the law of what? Syllogism, right? So now my conclusion will be the first part. So all bibbles play bubbles. You see? I take the first part and the last part. So all bibbles play bubbles will be the statement that I can write for that. Now, this is the crazy part. I love the way that they rewrite this in if-then form. Ready? If something is a bibble, then it is also a bauble. If something is a bauble, then it plays bubbles. It's the same kind of concept, right? It's still the law of the law of syllogism. And putting it together would say if something is a bibble, then it plays bubbles. Okay? Just makes it a little easier to read, I guess. Any questions there? Guys, I need to know if you have questions for Rowan. No? Okay, that's all the notes, so that's all I need.